Hi Ling. Finally, I have finished the rework of Lab 5. Why is it so late? Because only in last 2 days, uh, I other people from other team, a person from another team told me that I need to modify the kernel code before I compile it. So because of it, I finally find a solution. But anyway, I will show you what I have did in this lab. First, I built a EC2 with 30 GB, and then I create a slab place, as you can see. Next, I modify the etc app sources and download all the libraries, all the code in Linux. Okay, next I will show you what I have done to what I have modified in the kernel code. Thank you. I will explain the work I do in Lab 5. In Lab 5, from the paper, we know that when the RT or the estimated value of the round trip time is larger than the round trip time RTT, we do not have to use exponential backoff algorithm. And also, when the network is very lossy, which is the package loss is mainly because of corruptions rather than congestions. We do not have to cut the congestion window size by half. So I will show you the code I modified in the kernel. First is the TCP.C. So here I disable the update of the timeout. So it will only set to the RTO mask. Similarly, I disable the update of the timeout. I don't want any update of it. And also, in the function of TCP disconnect, when a disconnect happens, I want the window size to be 10 rather than 2, so it will slow start faster. Here, this is all I did in the TCP.C. So next, in TCP COG congestion control.c, I set, in the slow start function, I set the value to be clamped to the clamp, so it does not have to grow from a very small value. Wait. And also here I don't want the slow start threshold to be at half of the congestion window size. I just want it slow start from the congestion window size. Here I want to set a time to be a constant value, which is the free RTO base, which is free RTO mean in most of the time. Here I disable any backoff and retransmit. Here I don't want the backoff to be updated. That's it. I also modified the input file. So I set the buffer to be larger. And that's it. That's all my modifications. Mistake I have made. So here I should uncomment the retransmit. The transmit number is very important to invoke the fast retransmission function. So I should uncomment here. in the TCP timer.c. Thank you. Compile the code I just modified. So config. Yeah, I'm compiling it. Now we have finished all the compiling. We need to modify the two configuration. So in the first configurations, I add up all the, the, the kernel I add. And in the next one, yeah, I've modified it to the correct version. That's it. So next, I will reboot the machine. Everyone, so now let's do some tests on our server. First, I will use iPro3 as a simple test, and then I will use FTP server, FTP transportation. So I've set up a iPro3 server here, and then let's try it with no latency and no loss rate. As you can see, the bandwidth is very high, and then let's add some latency and add some loss rate on it. I set the latency of 200 microseconds and set a loss rate of 20%. Okay, now let's do some tests. And then, so here. I'm going to say it should be a longer period. As you can see, the throughput is very good. It's very close to 10 megabytes seconds. Okay, later I will use FTP server to do the to do a precise test. Thank you. So let's test it with FTP. We do the same thing. We add a handler at a delay as 200 microsecond and drop rate of 20%. Then I test it. So it may take a while to connect. So I will show the result later. Okay, so it is down. The average throughput is 1 megabyte. So I times 8 divided by 100 is like 8%. That's really decent for me. That's it. Okay, so that's all of our report. Thank you.